Okay, so in this video, I'm going to talk to you a little bit about what are called trigonometric identities. And an identity is an equation that is true for every value of the variable for which the variable is defined. So just real quickly, like in algebra, we have identities, and here's a pretty typical one. So if like you have 5 times x plus 3, that's equal to 5x plus 15 because of the distributive property. And this is always true. No matter what I plug in for x, this is a true statement. Whereas if I had something like this is only true when x equals 4. So this is not an identity because it's not always true. Whereas in this case, no matter what I plug in for x, both sides are going to be equal. So what I'm going to teach you about now is what are called trigonometric identities. So think of them like as formulas that you can use in problems or like substitutions that you can make. Okay. So again, I'm not going to make you memorize these. You'll get the formula sheet the whole time, and this is what the formula sheet looks like. So everybody has a copy of this that they use in class. Hopefully you're seeing that. I think. I don't know what you're seeing, so hold on a second. Yeah, so hopefully you're seeing that formula sheet right now. In any case, I'll attach it to the email that I send you. But this is the formula sheet that you'll get to use. And as of the end of this video, you should be able to use all the identities on the left-hand side here. And then in class, we know all of these on the left, plus we know cofunctions. And 2 days ago, we started learning about the sum and difference formulas. So by the end of the class, you'll know all the ones on the front. But by the end of this video, you should know the first column and then the top row in the second column. So let me show you how to use some of the identities. So these 6 here, so 1, 2, 3, 4, 5, and 6, those are called the reciprocal identities. And you actually already know those because it's just saying that the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So those are the reciprocal identities. The quotient identities are that tangent is sine over cosine, and that cotangent is cosine over sine. So those are the quotient identities. The new ones are called the Pythagorean identities. So I'm going to write down the 3 Pythagorean identities for you. And again, you don't have to memorize these. So I'm not going to go into detail about how they were like created or anything like that. But the first Pythagorean identity says that the sine squared of an angle plus the cosine squared of an angle is always equal to 1. So no matter what angle you plug in there, if you do sine squared of the angle plus cosine squared of the angle, you always get 1. So I'll show you an example. If we look at the sine of 30 degrees, that's 1/2. And we know that the cosine of 30 degrees is √3 over 2. So if we plug those into this formula, we should get a true statement. So the sine of 30 degrees, so let's do sine squared 30 plus cosine squared 30. And let's see if that's equal to 1. The way you do this, just so you know, if you have the sine squared of an angle, that's the same thing as taking the sine of the angle and then squaring that result. It is not this. So it's not sine squared theta because that would mean to square the angle and then take the sine of it. So that's not true. So the way you do this is the sine of 30 is 1/2, and then we're going to square it. And then the cosine of 30 is √3 over 2, and we're going to square that. And we're going to see if that's equal to 1. So 1/2 squared is 1/4, and then √3 squared is 3, and then 2 squared is 4. And so we do get a true statement that 1/4 plus 3/4 is equal to 1. So this is an identity that's always true. So sine squared plus cosine squared is 1. The other 2 identities are 1 plus cotangent squared is equal to cosecant squared. And the last one is tangent squared plus 1 is equal to secant squared. So there's 3 Pythagorean identities that the kids in class have to memorize. You just have to be able to use them. So that's the first one. This is the second. And here's the third. So you should see those on your formula sheet. And I'm going to show you how we're going to use those to start. Okay. So if we go down here, and we won't worry about that right now, we'll just go ahead and do this example right here. Okay. So if we look at this problem, it says that we're told that the tangent of an angle is -8. We're told that the sine of the angle is positive, and they want us to find the sine of the angle, and they also want us to find the cosine of the angle. So if you have tangent, there's the only trig identity that you can get directly from knowing the tangent without like doing kind of any work is that we know that cotangent is -1/8 because tangent and cotangent are reciprocals. So I'm going to write that over here, but we're not using it. So I know that the cotangent is -1/8 because tangent and cotangent are reciprocals. Now, if I look and I see that I want the sine and cosine, I'm not going to be able to get directly to either of those by just knowing tangent and cotangent. So I'm going to have to use one of the Pythagorean identities. I could either use 1 plus cotangent squared is equal to cosecant squared because I have the cotangent right here, or I could use tangent squared plus 1 is equal to secant squared. Now, neither of those are going to give me sine or cosine directly, but I know that if I have the cosecant, I can take the reciprocal and I can get the sine. Or if I have the secant, I could take the reciprocal and get the cosine. I'm going to go ahead and use this identity, but again, you could use either one. So I know that tangent is -8, so I'm going to do -8, but we want tangent squared, so I'm going to square that. And then plus 1 is equal to secant squared. So -8 squared is 64, plus 1 is equal to the secant squared. And so this is 65 is equal to the secant squared of this angle. And then I'm going to go ahead and take the square root of both sides. Okay, so that means that the secant of the angle is either positive or negative root 65. So here's where we have to make a decision. I have to figure out if secant is positive or negative. So if I look at the information they gave me, they're telling me that my tangent is negative. And then if I look here, it's telling me that my sine is positive. So I know that tangent is equal to sine over cosine. Well, if tangent is negative, okay, and I know that my sine is positive, then what does my cosine need to be in order to give me a negative when I divide? So if cosine were positive, a positive divided by a positive would give me a positive. So that's not what I want. So my cosine needs to be negative here. So if my cosine's negative, then my secant has to be negative. So now I know that the secant of this angle is negative root 65. I still don't have what they're asking me for because they're asking for sine and cosine. But I know that if secant is negative root 65, I know that the cosine of an angle is the reciprocal of secant. So I can just say that the cosine is 1 over negative root 65. And then I have to rationalize that. So I would multiply the top and bottom of the fraction by root 65. And so that result would be that the cosine of the angle is equal to negative root 65. And then root 65 times root 65 is 65. So finally, after all of that, we now know the cosine of this angle. Lastly, they want us to find the sine. And while you could start all over and do this Pythagorean identity and get cosecant and flip it, now that you have two trig functions of an angle, you can probably use one of the other easier trig identities And now that we know tangent, well, we know, again, I wrote it over here, we know that tangent is sine, which is what we're looking for, over cosine, and we actually have tangent and cosine. So we know the tangent is -8. We don't know the sine, so we'll be looking for that. But we know the cosine is -√65 over 65. So if we just solve for sine, we'll be done. Well, to undo division, we multiply. So we're going to take -8 and we're going to multiply it by -√65 over 65. And that's going to give us a sine value. And so if we just multiply this out, we have a negative times a negative, so it's positive 8√65 over 65. And that's equal to the sine of the angle. And then if you look, it said that sine should be positive, and that's what we got. So it's literally looking at what you're given and then just using the formulas / identities to get to something else. Okay, so I'll do another one with you. In this one, they gave us cotangent, and they want cosecant, and they want tangent. So this is super easy to find tangent. You just take the reciprocal of -3. So tangent would be -1/3. So we're done with the tangent part. Now that we have tangent and cotangent, there's no quotient identity that's going to get us cosecant because that's the reciprocal of sine. So we have to use one of the Pythagorean identities. So the probably quickest way is 1 plus cotangent squared is equal to cosecant squared. So 1 plus -3 squared is equal to the cosecant squared. So this would be 1 plus -3 squared is 9. Cosecant squared. So this would be 10 equals cosecant squared. And so cosecant is equal to positive or negative square root of 10. If we go up here, we have a little more information to the puzzle, but unfortunately they're telling us cosine, so like is negative, but that doesn't tell us anything about cosecant, so we have to like kind of figure it out. So I see that my cotangent is negative, so I know that cotangent is cosine over sine. And let's see, I know that my cotangent is negative, and from this inequality right here, I know that my cosine is negative, so my sine would have to be positive, so that when I do a negative divided by a positive, I get a negative. So that gives me that the cosecant is -√10. So we did what they asked. We found the tangent by just taking the reciprocal of cotangent, and then we used the Pythagorean identity to find the cosecant. The next set of identities I'm going to show you are called the cofunction identities. I'm going to show you kind of a drawing so that you understand these. So I'm going to steal these from here. And let's see, how do I want to do this? I'm going to kind of put it on another page and draw you a picture. So you might be wondering how the trig functions were named, because they're definitely not named by the reciprocals. So for example, sine and cosecant are reciprocals, and that name, like the naming convention there, doesn't really make any sense, right? It's like sine and cosecant, like how are they related, right? And then you have secant and cosine. The only one that kind of makes sense is tangent and cotangent, right? So, but like the way that the trig identities were named is that they were named with their cofunctions in mind. So sine and cosine are cofunctions. So sine and cosine are cofunctions. And then you have secant and cosecant. They're cofunctions. And then the only one that's kind of related twice is tangent and cotangent, because they're cofunctions and they're reciprocals. So then you have tangent and cotangent. Those are called co-functions. So how do co-functions work? Well, this statement right here is really important. And what it says is if you have two co-functions and you have two angles that are complementary, which means they add to 90 degrees, then those results are going to be equal. So for example, if you have the sine of 30 degrees, that's going to be equal to the cosine of 60 degrees. If you have the tangent of, let's say, I'll do angles that aren't on the unit circle. So like the tangent of 10 degrees, if you knew what that was, that tells you that you also know the cotangent of 80 degrees. And if you know the cosecant of 5 degrees, then you would know the secant, because they're cofunctions, of 85 degrees. So if two angles add to 90 degrees, their cofunctions are equal. And that's what this says. If you know the sine of theta, you know the cosine of, and then pi over 2 is 90. So you know the cosine of 90 minus theta. So that's literally all that is it's just saying that if you know the sine of an angle, you know the cosine of its complement. If you know the cosine of an angle, you know the sine of its complement. So like if I tell you, hey, the cosine of theta is 1/3, and then I ask you for the sine of 90 minus theta, these two things are equal, so you know that this is also 1/3. So that's cofunctions. And again, you don't have to memorize the formulas. I'm going to let you use them, but just kind of be aware that they exist. All right. The last set of identities that I'm going to talk to you about now are called even and odd identities, and those are right here. I'm not going to go into super depth about what it means to be even or odd, but these angles, or I'm sorry, these identities, you only use these, so only use with negative angles. So these are only used with negative angles, okay? So what that means is, so like if you look at this statement right here, it says that the sine of negative theta is equal to the opposite of the sine of theta. So if I want to know the sine of negative 30, then I know that's just the opposite of the sine of 30 degrees. Well, I know the sine of 30 is 1/2, so the sine of negative 30 would be negative 1/2. So sine and cosecant and tangent and cotangent are what we call odd. And if you look, odd produces the opposite result. So all of the odd functions, if you want the trig of the negative angle, it's equal to the opposite of the trig of the positive angle. Cosine and secant are even. And so, for example, if you want the cosine of negative 60, that's just equal to the cosine of 60. So there's no difference there. And those are called even. Okay, so I'll kind of show you how to do a few of those. So we'll go down here. So the cosine of negative 45, if you look at your even and odd identity, cosine's even, so this is actually just equal to the cosine of 45 degrees, and the cosine of 45 is root 2 over 2. If you want the sine of negative pi over 6, that's actually, since sine is odd, that's equal to the opposite of the sine of pi over 6. And the sine of pi over 6 is 1/2, so this would be negative 1/2. Tangent's also odd, so this would be the opposite of the tangent of 60 degrees. So this would be negative root 3, because the tangent of 60 is positive root 3. Secant is even, so this would actually just be equal to the secant of pi over 2. Well, let's see. The secant of pi over 2 is the reciprocal of the cosine of pi over 2. The cosine of pi over 2 is actually 0, so this would be undefined. And then lastly, cosecant is odd. So if you want the cosecant of negative pi over 4, That's the opposite of the cosecant of pi over 4. The cosecant of pi over 4 is root 2, so this would be negative root 2. Sorry, one more. Cotangent is also odd, so this is the opposite of the cotangent of 30. The cotangent of 30 is root 3, so this is negative root 3. Okay, so just so you know, where I'm getting all of those is if you look at your formula sheet, you have these even and odd identities right here. So you just have to look at them and see if a negative turns to the opposite or if the negative disappears because there's no negative here. Okay, so those are the ones that you should practice. I will attach a practice sheet to the email that I send you. And so just like take a look at this video and see if you can get those practice problems done.